Hello everyone, in this video, we will be presenting our project for the course MAT300, which is focusing on ordinary differential equation. Our chosen subtopic is Newton's law of cooling or warming. Here is the table of contents for this video. First, we will introduce ourselves and the members of this group. Next, we will define Newton's law of cooling or warming. Then, we will present the problem statement and a case study related to it. After that, we will provide the solution to the problem statement. Finally, we will conclude the video by summarizing the topic and revisiting the problem statement. Let me introduce our team members.
Hi, my name is Nozaira binti Aziz and my ID number 2021688198.
Hi, my name is Siti Nuralisa Darlina binti Hamidun and my ID number is 2021624382.
Hi guys, my name is Izzati Zukrina binti Muhammad Rasdi and my ID number is 2021626268.
A formula that describes the cooling or warming of an object over time. It states that the rate of heat loss or gain from an object is proportional to the difference between the temperature of the object and the temperature of its surrounding. The law is expressed as above, where dt over dt is the rate of change of temperature over time. K is the constant of proportionality that depends on the properties of the object and its surroundings. The big T is the temperature of the object and Tm is the temperature of its surroundings. Here are some examples for the Newton's law of cooling or warming. One of the examples is melting ice cream. Newton's law of cooling can be used to determine the rate at which ice cream melts. Second, cooling down of hot beverages. The time taken by a hot beverage to cool down is easy to calculate with the help of Newton's law of cooling. It must be observed that a hot beverage cools down quickly during the first few minutes of exposure to the room temperature. And last but not least, for forensic science, detectives and forensic scientists use Newton's law of cooling to determine the time of death of a victim by measuring the temperature of the dead body and the room temperature of the crime scene.
This video shows initial condition before the meat grill. If you can take a look, his surrounding is on the afternoon. So let us put the time he start cook at 12:30 p.m. The surrounding temperature also must be high, and let's say is 90.5 degree Fahrenheit.
We have a crust on this side, now I'm gonna flip it over. Oh, completely raw.
He must take a long time to get the meat full grilled, maybe around 30 minutes. So, after he done cook, maybe around 1 p.m, the temperature of meat is at 157.1 degree Fahrenheit.
Cooked one. It's almost well done. This is like...
Have you ever think how many more time taken to eat the meat?
Now, let's look at the question. The cooking started at 12:30 p.m. and it took about 30 minutes to fully grill the meat, and the meat was put aside. The surrounding temperature is 19.5 Fahrenheit. The temperature of the meat is 157.1 Fahrenheit at first, as soon as the meat is done. After 50 minutes, the temperature of the meat is 120.5 Fahrenheit. If the meat can be eaten at 100 Fahrenheit, then at what time they can eat? Now, let's do the calculation together. To form the general equation, we have to use this formula. D capital letter of T divided by dt equal to K in bracket T minus Tm. Capital letter T will be put at one side and the other on the other side. Integrate both sides and make it capital letter T as a subject. Therefore, we get capital letter T equal to AE to the power of KT plus 90.5. After that, we get the information from the question where actual temperature of the meat after it's fully grilled is 157.1 Fahrenheit. Actually, this information can be interpreted as T0 equal to 157.1. Therefore, we substitute lowercase t to 0 in the general formula we get just now, and we get constant A equal to 66.6. Next, other information that we have is after 50 minutes, the temperature is 120.5 Fahrenheit. And once again, we can interpret the information to T50 equal to 120.5. Substitute lowercase t equal to 15 and the equation is equal to 120.5. Therefore, we can get k equal to negative 0.0532. K value is negative because of the temperature is getting lower. Since we already found the value of constant a and k, we can finally find the time. Therefore, we put lowercase letter of t first. The information interpret as capital letter of t in bracket lowercase letter of t equal to 100. Then, we put lowercase t as subject. Then we get 36.58, but we need to change it to hours and minute. Therefore, we get 36 minutes. Lastly, the time the meat can be eaten is 12:30 p.m. plus 30 minutes for the time the meat to grill and 36 minutes from what we have counted just now. And the meat can be eaten at 1:36 p.m.
To conclude, using the given formula, we can determine the time required for meat to be safely consumed at temperature of 100 Fahrenheit. Based on the calculation, we can predict that the temperature of the meat will drop to 100 degree Fahrenheit after approximately 36.61 minutes, assuming the cooking process done at 1 p.m. after meat fully grilled. So, the meat should be ready to eat at around 1:36 p.m. This video explains how Newton's law of cooling or warming can be used to estimate the rate of temperature change. By applying this knowledge, we can accurately calculate the time needed to reach our desired temperature, whether we are cooling or warming the substance. This is our reference page. This is a video from YouTube for our case study. That's all from us. Thank you for watching until the end.